everyone, and welcome back. My name is Mr. Cobalt, and in this video, I'm going to be going over how to calculate the change in free energy for a reaction under non-standard conditions, problem number 2. So in my last video, I did a problem. So now in this video, I'm going to do another problem to try to help you out a little bit more. So in this problem, we are given 2 moles of H2S gas plus 1 mole of SO2 gas, and that's going to give us 3 moles of solid sulfur in the rhombic structure plus 2 moles of water. And so this is the reaction here. This is our equation. And we're given that the standard free energy change of this reaction at 298 degrees Kelvin, which is your standard temperature. That's going to be negative 102 kilojoules. So what about under non-standard conditions? So we're given the partial pressure of H2S gas at 2 atmospheres, the partial pressure of SO2 gas at 1.50 atmospheres, and the partial pressure of water at 0.0100 atmospheres. So there's our non-standard conditions. So let's get into this. So the first thing we want to do is find Q, because we're going to be using this equation. So we have the free energy change of the reaction under non-standard conditions is equal to the standard free energy change of the reaction plus the ideal gas law constant R multiplied by the temperature multiplied by the natural log of Q. Now, Q is the reaction quotient. You'll remember Q from your from the equilibrium equations, right? So you have the law of mass action for equations that have an equilibrium where they're reversible, they can go backwards. And so Q, if you remember, is the reaction quotient for when you are not at equilibrium. So what conditions are you in? So we need to calculate Q first. So we'll calculate Q. So Q is going to be equal to, again, it's going to be products over reactants. So we have the products here. So solids and liquids do not belong in the expression for Q or K, the equilibrium constant. So we'll ignore the solid sulfur here. And let me just double check that we have, yes. So this is a gas, gas, gas. So that's all going to be in our expression. So water is a product. So we're going to put the partial pressure. So it's going to be the partial pressure of water. And notice that water has a 2 coefficient. So we're going to raise that to the power of 2. Because according to the law of mass action, that's what we do. And now we got our products. Now we're going to do reactants. Reactants are on the bottom. So we have H2S, so the partial pressure of H2S. That has a 2 there, so we're going to put that as a power of 2. And we're going to multiply that by the SO2, the partial pressure of SO2. And since there's a 1 there, then that's going to be a 1 there. So now all we need to do is plug in the values that they gave us. So the partial pressure of water is there. So we have 0.0100 atmospheres, or we don't really need to write atmospheres here. The units are going to cancel out anyway. So that's going to be squared. Then we have H2S. So the H2S is 2. So we have 2.00 squared and multiplied by the partial pressure of SO2, which is 1.5. So we have 1.50 not squared. And so all we have to do is do this calculation. And when we do, we get our answer. And we get, for an answer, 1.667 times 10 to the negative 5. So there's our reaction quotient. So we can plug that into Q here. And so now all we need to do is write our equation. But before we do that, notice that the R value, let me write that down, R is equal to 8.314 joules per mole Kelvin. And so we have joules here, but we have kilojoules here. So let's convert that to joules. So we have, I'll write it here in this space provided. So we have 102 kilojoules over 1. I know that 1 kilojoule is equal to 1,000 joules, so I'll put 1 kilojoule on the bottom, 1,000 joules on top. Kilojoules cancel out, and so I end up with, let me make sure I have room, that's going to be 1.02 times 10 to the 5th joules. So here, let me write that out clearer. So I have 1.02 times 10 to the 5th joules. That's much better. All right, so here I have my standard free energy change in joules, so we can plug everything into our equation. So the free energy change of a reaction, of this reaction, is equal to the standard free energy change of the reaction, which is 1.02 times 10 to the 5th, 1.02 times 10 to the 5th joules. And this is like joules per mole, but we're ignoring the per mole. And we're going to add to that R, so that's 8.314 joules per mole Kelvin. And then we're going to multiply that by the temperature, which is 298 Kelvin. And the natural log of Q. And of course, we calculated what Q is, so we'll just put that in. So we calculated Q here, so that's going to be 1.667 times 10 to the negative 5th. And so now we have everything set up, and we just need to calculate our, oops, one thing I forgot, don't forget the negative here. You probably were at home saying, Mr. Cole, you forgot the negative. Yes, I did. So don't forget the negative. Okay, we got everything right now. So let's go ahead and calculate this out. And we get, so this is going to be equal to negative 1.02 times 10 to the 5th joules. Here, Kelvin cancels out. And so we'll ignore the per mole here. When we calculate this, we get negative 2.7258 joules. Oops, forgot the times 10. Times 10 to the 4th. 27, let me double check. 25, oops, I transposed these. It should be 258 times 10 to the 4th joules. And when we add that together, we get negative 1.29 times 10 to the 5th joules. And if we convert that to kilojoules, it would be negative 129 kilojoules of energy. So in this case, we can see here that under these non-standard conditions, we get a more negative value for the delta G. And compared to the standard free energy change. So under standard conditions, we are less spontaneous because it's less negative compared to these non-standard conditions. So under these particular non-standard conditions, this reaction is actually more spontaneous. So I hope this is helpful. If you learned a lot from this video, if this helped you in any way, if you enjoyed this video, then please like the video, share the video with your friends. Also, don't forget to subscribe to my channel, hit that notification bell. Also, click all when you do, so that way you can be notified by all the videos I put out. And finally, put a comment down below. Let me know what you think. Ask me questions. I would love to hear from you. Thanks for joining me, and have a great day.